Hello everyone, welcome to day 2 of the OpenSAFELY, or not OpenSAFELY, the Bennett Institute Symposium. I think it's about OpenSAFELY because that's what I work on and it's what I'm here to talk to you about this morning. How many people here are already familiar with OpenSAFELY? Okay, cool, so I'm going to be teaching some of you to suck eggs a little bit, somewhat. How many people aren't and don't really think they know what an OpenSAFELY is? Well, I will be coming around to ask you how you feel after 15 minutes' time. So OpenSAFELY is one of the pieces of technology that we build and maintain here at the Bennett Institute. And the way that I like to talk about it is that it's both a philosophy of using sensitive data for research and for analysis, and also the set of software tools that we have built and the policies that we have implemented to enable people to act on that philosophy, specifically in the domain of electronic healthcare records in the UK. And that philosophy is, we've got some nice little cartoons that I know Benji likes to use to illustrate these. So let's say that you are a healthcare researcher and you would like to understand what's going on in GP records. Somebody goes to their GP and they receive a diagnosis or perhaps a prescription of some medication, and that goes into their record. Now, if I'm actually going to be doing some research alongside, okay. Noted, changing slides might be a little janky. That goes into their record, and as a researcher, I want to be able to investigate that record. But while I'm doing actual sort of investigative research and things like that, it doesn't make sense for me to have access to those actual sensitive data records. So instead, what we do in OpenSAFELY is we don't allow researchers access to those directly. Instead, researchers will work primarily with dummy data, fake data, and while they're developing their code. And then once they've developed that code that runs against dummy data that they can use to test all the things that they're trying to do, they then give that code to us, and we do remote code execution as a service. Apologies for the flashing of the slides. So they submit that code to us through GitHub. That code then runs in the secure backend of the data provider for whichever data source that they're trying to use. At the moment we have TPP, and we are currently in talks with OptimEMIS to open that back up as well. And then that code runs in the secure environment where the data lives naturally inside all of those layers of security that data has on a day-to-day basis. So the researchers never touch the code directly, never touch the data directly. Their code does, but it's operated at a distance through several layers of both process and technological security. Once their analysis is run in place, their outputs will be made available back to them in what we call an airlock, which is, I think, fairly standard thing in secure data research, where it's a sort of researchers can see their insights, but they're not made publicly available until they have passed review by at least 2 output checkers to check for things like disclosivity and other things that would prevent these insights being appropriate to release to the public. Once all of those checks have been completed, the researchers can then use those insights to write papers, inform policy, do whatever they would like with the results of their analysis that's been run against this sensitive data. So we've had over 100 outputs from OpenSAFELY since the start. We've looked at questions such as who gets COVID-19, what sort of demographics are most vulnerable to them, what are the transmission risks that are in different situations. So obviously OpenSAFELY was started during the pandemic because we needed to be able to answer these kind of questions. Things like, do COVID treatment work? Who gets them? Do specifically vaccines work? Are there any adverse effects? Obviously it's sort of a hot button topic in some places in the world right now, and being able to answer those questions with hard data is incredibly valuable. And things like, what are the population level impacts of the COVID pandemic? What is long COVID doing to us? Who is getting it? And then also service level questions about how the NHS is handling issues to do with population level health. So what makes OpenSAFELY special? 2 things, trust and efficiency. And what we mean by trust is that we work with the NHS and the GPs as the data controllers. So we don't claim ownership of this data at all. We are interfacing with the people who do control this data. And that means that we don't actually have to, we just have to convince them that we're going to be responsible in the way that we allow researchers to interact with it. The records don't move, as I've said, they live within the secure environment. And by not moving secure data out of where it sits as a default, we eliminate entire classes of problems that can arise out of using secure data. When users are creating their code, they're working with dummy data. This has both pros and cons. Obviously, the pros is that you aren't risking any kind of disclosivity or data breach when you're working with data that is completely fake. But at the same time, there are nuances that are present in the real data that will not be in sort of artificially generated data. But the main thing about the trust that I think is really important to OpenSAFELY is that it's all completely open. It's in the name. All the software is open source, and all of the code that researchers write eventually becomes open source as well as part of our policy of allowing researchers to use the platform, which means that anybody can go and look and see what is being run. So you can go to the GitHub OpenSAFELY core organization to see what the software that we build and maintain is, and you can also go to the OpenSAFELY organization to see all of the studies that have been written by researchers using OpenSAFELY. Efficiency is the other half of this. We have standardized open code with our domain-specific query language, ERCL, Electronic Health Records Query Language, and I will show you a little bit of this live in a couple of minutes. In terms of open working, we've got various reasons for wanting to do this. Open code is obviously good for transparency. Any member of the public could come and see what code is being run against the secure data that is essentially theirs. If there are somebody who has GP records about them, they should be able to see what code has been run against their data and how it's being used. And that's one of the things that OpenSAFELY provides by default. It also is good for users because it means that they can learn from other users, and they can sort of look at what other users have done in the past, collaborate, and learn from each other. And it's good for quality because it means that we can all sort of look at each other's code. It's all kind of the same thing. The transparency drives up the quality, meaning that when you, as a user, are looking at previous users' code, you can learn from best practices that are already in the field. They're not shut away from you. Right. Engineers and researchers working together is also a core part of how we work at the Bennett Institute. So hands up researchers at the Bennett in this room. Yep, hands up engineers at the Bennett in this room. Yep. And we all know each other, work together, discuss these problems together, and come at problems from the different angles based on our expertise to find a solution that actually works both technically and for users. And my job is to help researchers get what they need and find technical solutions from the tech team to meet their needs. Part of that is our user support and documentation, also a very big part of my job. So we have the co-piloting program at OpenSAFELY, which is where we have knowledgeable researchers who will help onboard newer researchers, help them through that learning curve of onboarding onto the platform, because there is quite a learning curve because the domain that we're working in is intrinsically complex. And so we have quite a hands-on approach to helping people get the most out of the platform. It's also a modular approach in that when you have open code in this way, you can chop and change and take little bits of it, and you don't have to take an entire approach from somebody else's study or the way that they've handled a certain problem in order to still gain benefit from what it is that they've done to solve a problem. And all of this equals tangible results. We have had incredibly successful run so far with OpenSAFELY in terms of both value for money and how many outputs we've had. One of the things that we're doing at the moment is gearing up to make non-COVID research possible with the platform, which is going to just, hopefully be an incredible source of potential, insights, research, policy informing, sort of outputs. So that is OpenSAFELY in a nutshell. And one of the things that I want to talk a little bit more about, or the main thing I want to talk more about, is the query language that we use, because it's sort of at the heart, I think, of what makes OpenSAFELY possible. So working with electronic health record data is really difficult because it's not standardized necessarily. There's a lot of nuance, there's a lot of sort of domain-specific knowledge that goes into understanding what it means and how to work with it. So we've got all sort of different levels of preparation that the data might be in any given sort of when you interact with it. So raw GP data is different to analysis-ready GP data. You've got things like free text fields that might need to be normalized, things like this. And converting from one to the other is complicated, and there's no standard way of doing it. So, yeah. That's a Benji classic. I think he drew those little colorful lines. So how do we handle this? Well, we need to standardize ways of working with it. If the problem is that ways aren't standard, then we should change that, right? And this is what we have tried to do with Urkel. So Urkel is a piece of software. It's a sort of Python package, essentially. And I think it's one of the best pieces of software I've ever seen. It's really incredible. And when researchers use it to write code, what they're doing is they are sort of interacting with this health record data in a sort of abstracted way that means that the code can be reusable across potentially different backends. And it means that querying different columns and things in the data looks and feels similar. So you can reason about it more easily. It makes the code much more readable. It makes it reusable. It makes it composable. And you can see that when I'm about to do a bit of live coding in just a moment. And it makes it portable, and what we mean by that is that the same code could be run in both TPP and EMIS backends, and it would run in a very similar way, and you would have results that you're able to compare like for like once you factor out sort of any demographic differences in the patients that are in those backends. The code would be doing the same thing. All right, how are we doing on time? How much of a live demo do people want? I can speed through it, or... Live demo? Okay. Yeah. Okay, so this is the Urkel tutorial in the OpenSAFELY repository, OpenSAFELY GitHub organization. This is a repository that we make available for people to learn to get to grips with writing Urkel for the first time, or maybe the second or third time. And what you do when you use this is you use this as a template, and that creates a repository in your own GitHub account. And I have done that here. I have made one for today, Medicine Symposium presentation. And this is an OpenSAFELY study repository. What we have in here is we have things like, well, there's quiz and quiz answers that are specific to the fact that this is a tutorial. The screen's gone out again. It doesn't want me to show you. Yeah, there we go. And the important thing that we're going to look at here is this dataset definition. The dataset definition is a Python file. It's where you write Urkel code, and it's what you do in that dataset definition is you define which patients you want to be in your cohort, essentially, and what information about them you want to be available to your analysis code. So I have opened a code space. Well, I need to restart my code space. And this is the way that we sort of recommend researchers work. So you go to your code. Oh, my goodness. You go to your code, and you can have a code space, and that is essentially an editor that runs in your browser, which is really nice because it means that you don't have to deal with locally installing all of the tooling that we need in order to make OpenSAFELY sort of code run. We can make it available to you just through clicking a few buttons. Here we go. So here I have a dataset definition, and once it loads, it should have some nice color highlighting. There we go. Right, okay. For live coding, that's going to be a challenge. Cool. I wonder if I put my cursor all the way down here and then scroll back up, is that going to be stable? Cool, okay, let me just talk then and not touch the mouse pad at all. This is some Urkel code. Huh? Can people see that pointer? Okay, cool, right. And I'm away from my mic, but it's fine. So this is some Urkel code. This is the dataset definition. And what we've got here is some Urkel machinery, right? There's a show function which is used within the tutorial so that you can have a bit of extra visibility about what your code is doing. And the create dataset function, and that's the thing that you use in order to create your patient cohort and then define who goes in it and what you want to know about them. So every study will have an index date, and this is sort of the date on which your analysis is being run. It's usually in the past. Criteria I've got here, this is where so my plan for this was to sort of sequentially uncomment the code and let you see how that was affecting what was going on in the patients that were being output as part of the dataset definition. But this is Urkel code, so you can see that we're looking at patients and we're saying, I care about people who have a non-null birth date. If somebody's birth date is null, it's a good sign that there's something unusual about their GP record that means you might want to exclude them from your analysis. You can filter based on their age on the index date. So, for example, in this scenario, I would only be looking at people within sort of adulthood and not older than 80 or younger than 80 or who are on the index date in 2020. When I create my data set, I can then define the population, and the way that you do that is you say, well, I want people fulfilling these criteria. And you can see here, it's sort of, this is a truth statement, and I'm composing it with another truth statement and another truth statement. So you can think of this as a sort of Boolean logic table here that's being built up. The next thing that I was going to put in here, oh, don't we love computers? Was showing you how to use other tables, not just the patient's table, because there are multiple tables that you can query with an Urkel and that live in the back ends of the secure data store environments. So if we wanted to say, look at patients' practice registrations, perhaps you care about how often they've changed practice registrations in the past, are they currently registered? Here what I've done is, so on this line, I'm filtering who goes into my population. Further down, what I'm doing is I'm then annotating that group with information about those people. So there's two sort of stages when you're writing Urkel. There's one which is like, who do I care about? And then there's, what do I care about them? And so here, all I'm doing is I'm annotating that data set with the registration date that their current practice registration started. This won't exist for every patient. Some patients don't have a current practice registration. So if I run this entire code, I'm going to uncomment that, and we're just going to have to deal with the flashing screen for a bit. I'm so sorry. I'm not going to show the patients. And what I'm doing right here at the end is I'm enabling the show command, which when I hit a particular button, is going to bring up a panel which shows what a data set kind of looks like. So I hit that button. It's the interpretive dance of like, please work. This does just take a while the first time you load it because it's loading the Urkel engine, essentially. So what we have here, there's patient IDs, and these patients are being drawn from this dummy tables directory over here in the Urkel tutorial repository. We provide dummy patients for you. As a researcher, you could put whatever you wanted in there, or you could let Urkel auto-generate dummy data for you. There's lots of different ways to provide the dummy data that you work with when you're working outside of a secure environment. For this tutorial, we provide people with a preloaded set of patients that have sequential IDs, and you can see that not all of them are here. And this will be because some of them have been excluded by these criteria. Some of them will be older than 80, some of them will be younger than 18. And you can see that we've annotated it with the registration start date. Not every patient has this, and it's because they don't have a current practice registration. But for those who do, we've been able to add a column to the data set that tells us when was it that they registered with their current practice. And for some of them, that's very close to, so the index date here is the last of March 2020. This patient here registered just over a month ago with theirs. No date should be beyond that, though, because we were looking at the index date when we looked at the practice registrations table. And you can do quite complex sort of things. You could use that practice registrations to filter patients, for example. You could say, I only care about people who have a current practice registration because I want to know something, I want to investigate some property of that registration. How many times they've been prescribed antibiotics since they registered, or something. So in this way, you can build up very complex queries. You can query things like, so at the top, we've got practice registrations. There's also clinical events. Oh, where's my thing on clinical events, which obviously refers to diagnoses and medications. And you can compose and make all of these things interact to build up very complex queries. When this code runs in the back end, there are several really interesting technical things that happen, but the sort of spark notes is that it gets compiled down to a sort of agnostic way of representing the query that you have defined, and then and then it gets applied to whichever database you're aiming to query, because depending on which backend you've targeted, that might be different SQL engines, essentially. But this gets turned into a very abstract representation of the query that you're trying to ask of the database, and the way that Urkel does that, and sort of the way that all these different parts of it like combine to allow us to abstract over all of these different nuances and quirks and weirdnesses of EHR data is, I think, really incredible, very cool. If you are a code person at all, I do actually recommend going and looking at the Urkel code. I had a great time doing it, but that is pretty hardcore. But once you've written your code, you would write more analysis code in an analysis directory here, which doesn't currently exist. But that's where you'd put things like your R code, maybe you're writing Stata, maybe you're writing more Python. And then all of that runs all together in the secure environment. Once you submit your code to us, you get your analysis results back. Those get output checked, and then you go from there. And that is a high-level overview of OpenSAFELY. Thank you so much for bearing with me through the technical difficulties. And I hope I've been a good warm-up act for everyone else, and that you have an easier time with those